Okay, let me continue with machine foundation, introduction to machine foundation. Machine foundation is a full course, but very preliminary portion we will include in this, and already we have discussed vibration theories like forced vibration, free vibration, again forced damped, forced undamped, free damped, free undamped, and their corresponding governing equation, how to develop the equation and how to solve, and also finally what is their solution, all we have discussed. And in fact, I have taken a few problems also to make you understand how to use them. And once again I will summarize those final form, and in addition to that I will try to show what are the soil parameters, dynamic soil parameters required, and then finally how to determine them through IS, following IS code, Indian standard code. So, let me go to the first slide, and you have seen here that though we have two types of motion, actually free vibration or free or transient motion, and forced vibration or sinusoidal motion. And there and free vibration, of course, there can be many things like hammer foundation, or if I during or any if you strike blasting, then slowly the initial amplitude will decrease, that is all are free vibration. And now, if you have the forced vibration and that too sinusoidal type, then for that we have also discussed two types of force system can be there. One is actually that constant force system, that means in this of course there will be sin omega t can be there. Here also there can be a sin omega t, but we want, if I do not take this, then this is actually giving for a particular frequency what is the maximum value. So, because of that we do not consider this, we consider this as amplitude in millimeter. So, now in this constant force system means what? F equal to f naught sin omega t. One example, suppose it is 3 sin 40. If this is the equation, then your f naught become 3 and your omega become 4. So, this is one type of forcing system, that means 3, it has some unit maybe 3 Newton of force at a frequency at a speed omega, it is subjecting to any foundation, then it will produce some vibration. So, this is the force, in this f naught is this, and speed of the from there actually you can find out frequency of course, and that actually given by this. So, while solving problem we will try to explain this. So, this is one type of, that means constant force, that means this constant force 3 Newton or 3 kilonewton constant force is repeating at a particular frequency. So, that is one thing. Another thing I have mentioned that rotating mass system, that means as I have shown before many times, that if there is in a system there is a mass, eccentric mass, it is rotating with respect to some radius with some center, that means this mass will produce some centrifugal force which will be equal to m e times omega square, or I can write m e into r into omega square. This r is actually radius, that means, and which is nothing but eccentricity also. Sometimes we can write m e into e omega square, that means this is eccentric distance, or I can write simply r, because along the radius r it is rotating, and small m e is actually a mass of eccentric rotating part, and r or e is the distance from the center along which it is rotating, and omega is the speed. If, so, this type of, if there is in the machine this type of unbalanced part rotates with some center, with respect to some center, that also will create some vibration, and that actually if that is the one, then in that case we write force will be equal to m e into omega square sin omega t. Okay. So, this is the one, this is the force. Now, this force here actually f naught was constant, is repeating at a particular frequency. Here the force also, magnitude of force, dynamic force also depends on the speed omega. So, if the omega changes, then the force also changes. So, for this type of forcing system and this type of forcing system, the solution, corresponding solution, steady state solution is this, and for this type of forcing system, steady state solution is this. Now, we have got this solution, and this is actually at any frequency, and when u max, when you get displacement maximum, when actually omega over omega n equal to 1 or at a resonance. Okay. It may not be exactly 1. So, for this, what is the value omega over omega n, what is the value for this omega over omega n, what is the value I have shown last class. So, in the last lecture. So, I am not repeating that what actually this is actually general amplitude for constant force system at any frequency, that omega is here, omega can be 2, 4, 8 anything, and similarly for rotating mass system this is the steady state solution for any frequency at this is omega is there, but at resonance that amplitude become maximum, and expression for a maximum is f naught by k multiplied by this term, only damping will be there. This is already there, here also it is there. Additionally, instead of this big expression, only this expression will be there. Similarly, for rotating mass system u max is this thing is there already, and instead of this such a big expression we have got this. So, that means, if I want to find out at any frequency for constant force system, I will use this equation. If I want to find out resonance amplitude for constant force system, I will use this expression. Similarly, if I want to find out amplitude at any frequency for rotating mass system, I will use this expression, and if I want to find out the resonant amplitude for rotating mass system, then I will use this expression. So, this actually you have to be very familiar with. Now, I will just better whatever I written, I just clean it, and once again I will write few important thing. F naught already I have told that constant force magnitude, and this k actually this is capital K can be there. K is the stiffness, and your d is the damping, omega n is the natural frequency, and your and f naught k, and k is the stiffness already I have mentioned, constant omega natural frequency, and this is there. And when you come here, all those things are there. Additionally, there are 3 terms. So, m into E, that is mass of eccentric rotating part, and E is the eccentricity, sometime it is r, radius along which actually it is rotating, and your m, capital M is the mass of foundation plus machine. That means, if I imagine a foundation like this and there is a machine here, then because of this machine, this entire machine and foundation will vibrate together. So, these two together mass is m. So, m is the mass of foundation plus machine together. So, all those terms are known now, and omega is the operating frequency, and which can be varied. Okay. So, depending upon your requirement. So, all terms are explained now. Now, if I want to find out this amplitude or natural frequency from this, what are the things you require? You need to find out k, which will be equal to 4 g r by 1 minus mu for vertical vibration. I will discuss only vertical vibration, and in this g is the shear modulus and your r is the radius of the foundation and mu is the Poisson's ratio. Okay. So, all the k is required, m naught will be known. Then another thing is damping, d is the damping, that has, these are actually damping and shear modulus is the soil properties, and shear modulus and size of the footing together is actually stiffness. So, these are the things actually you need to find out. That means, you want to find out the amplitude. So, how to determine them? So, that actually there are some Indian code, actually there are of course, many places they do not follow similar method, but Indian code still follow that. So, we have to I want to discuss that, and you can go through that, and accordingly we will take some problem also. So, let me go to the next slide. You can see here that as per IS code, IS 5249, and it has several versions. So, 1999 was the last code revised, and there actually that things are given that you have to make a pit of sufficiently long, sufficiently big, and that pit should be at this depth, actually at what depth actually will be, it will be actually depth of foundation. How deep it should be? If the depth of foundation recommended from 2 meter, then you have to make the pit of 2 meter deep, and then appropriate size is also mentioned, and then you have to make a block of 1 meter by 1 meter by 1 meter by 1.5 meter, that means 1 by 1 cross section and 1.5 meter height, and if the soil is stiffer, then size can be made smaller. So, that recommendation also there. So, one concrete block has to be constructed, and then with that you have to put a oscillator, and then the oscillator can be operated through electricity, and then this block will be vibrated, and then at different frequencies amplitude can be observed, and that amplitude versus frequency versus amplitude can be plotted, and finally, from that plot one can find out many things that I will discuss now in the next slide. So, this is the actually experimental arrangement that you have to make a pit of certain depth, that depth equal to depth of foundation. Next, let me see, this is another arrangement, actually you can see here, this is actually given the plan view how it will be. This is the pit, actually on the pit there will be block, and on that actually motor and oscillator, this is the motor and oscillator, and from there it will speed control unit, through that through these actually it will be rotated directly, there is no connection, and then power supply etc. all will be there, and then there will be some pickup to measure the amplitude and frequency. So, this is actually the arrangement of test system. Once you change the frequency, and in this vibrator, actually this oscillator, that rotating mass type of system is there, 2 counter rotating mass is there, as I have shown before also, that 2 counter rotating mass is there, and based on that if it is here, then if vertical vibration is there, if it goes here, then if it is this way, then it will come here, this will come here. So, they will face each other, get cancelled. When it will be coming here, then it will be this direction, when it will be coming again this direction, this, so it will be cancelled. So, only produce this vertical vibration. Similar type of things are there in this oscillator, and then you change the frequency and observe the amplitude on the foundation, and then if you finally plot amplitude, frequency versus amplitude, you will get a typical curve like this. From this curve, what we will do, you have find out the peak amplitude, and then from the peak amplitude you measure what is the value, and then where the peak you are getting, you drop to the x axis and then read the x axis, that is actually natural frequency. So, natural frequency and resonance frequency little difference. If the damping is very high, then natural frequency and your resonant frequency is slightly different. actually at resonance frequency it is a maximum. So, it is actually truly speaking this is resonant frequency, and resonance frequency will be little different from the natural frequency, it is damping correction will be there, but if the damping is small then natural frequency can be approximated as a resonance frequency. So, that means this I can take as the amplitude frequency corresponding to maximum amplitude will be taken as natural frequency, and if you know the natural frequency and if you know that area of the foundation on which you have conducted the test, then using this equation I can find out the coefficient of elastic uniform compression. So, this is as per code coefficient of elastic uniform compression. Okay. So, this is actually your and Cu multiplied by A, it gives you the K, and how we are getting actually your Fn or omega n equal to under root k by m, and that means k equal to m omega n square, okay, and that means m into 2 pi f whole square. So, if I do this, you can see it is coming this one, k is coming this, and then Cu actually divided by you can see k become k will be equal to 4 pi square f n square m, and then Cu will be equal to 4 pi square f n square m divided by A, because your Cu multiplied by A is k. So, that is the way it is this expression given in the code itself. So, one can find out coefficient of uniform elastic compression, which is a parameter as per IS code. Now, if I conduct a test on a small footing, but actual footing size is big, then actually whatever from the test value we are getting, that cannot be used, and there is a need for correction, and that correction, if the foundation size actual foundation size is f and test foundation is A, then actual Cu to be used for the foundation Cu foundation actually will be corrected, can be corrected like the Cu multiplied by under root A over A foundation. So, like that it has to be corrected. So, if the foundation size is 2 meter by 2 meter, if actually you have tested suppose 1 meter by 1 meter, but your foundation size is actually 5 meter by 5 meter, then it has to be corrected taking AF equal to 25. But I have given an extreme example, actually if your foundation size is too big, more than 10 meter square, then AF to be used as 10 meter square. If it is suppose instead of 5 by 5 meter, if it is 2 by 2 meter or 3 by 3 meter, then AF will be taken 9, and if it is suppose 5 by 5, then 5 by 5 become 25, but limiting value can be used actually 10, maximum 10 can be. For correction, you can use this equation up to foundation area 10 meter square. So, if it is 2 by 2, you can use actual foundation area, if it is 3 by 3, you can use actual foundation, but when it cross 4 by 4, then it become more than 10. So, you have to use only 10. So, that is the correction. So, that means by observing, by conducting the test, you will obtain this response curve. From this response curve, you just identify what is the maximum value amplitude, and from there you produce, then you will get the what is the natural frequency. Once you get the natural frequency, put it in this equation to get the coefficient of uniform compression, and if it is the foundation size is different, then you correct the coefficient of elastic uniform compression for design by using this equation. And then for determining the damping, so if this is the response curve as I have shown previous one, similarly you may get like this. So, that is called bandwidth method or to get average damping. Actually, see, you can see here how we have got, if it is maximum amplitude x m, then you multiply by 1 by root 2 x m. Suppose if it is suppose 100, then 1 by root 2 multiplied by 100, whatever value it comes, suppose it is some 60 or whatever, maybe it is x and that is 60, then I will read 60 here, I will read 60, you will have two frequency. corresponding to amplitude 60 we may get 2 frequencies. So, lesser that before resonance whatever frequency you get that is called F2, and beyond this one we are getting suppose F1, and then from this or you can write F1 and this is F2, this is better, and in that case it will be expression of damping will be F2 minus F1 by 2 Fn. So, Fn is here and F2 is this one, that means whatever xm you are getting multiply by 1 by root 2, then that corresponding to that amplitude you will get 2 frequencies. Before resonance whatever we are getting that is called F1, after resonance whatever you are getting that is suppose F2, then read from this graph F1, F2 and Fn and then put in this equation to get the damping. Okay. So, this is actually from the block vibration test. Now, actually this is the one actually free vibration I have shown, and we have the expression for this oscillatory things actually we have given, and it can be shown that if you take this is the peak successive peak ratio of successive peak if you take and take logarithmic, that is called logarithmic decrement. The log of successive log of ratio of successive peak is called logarithmic decrement, and if you do take ratio of successive peak if you take log which is defined as logarithmic delta, and using the expression we can prove that that value finally comes like this 2 pi d under root 1 minus d square. If d is small then this can be approximated as 2 pi d, and now then we can write you can see then d can be 1 by 2 pi ln xn minus 1 xn. So, successive peak between 1 and 2 can be the always this delta will be constant. Similarly, between 2 and 3 the ratio will be log of ratio will be same. So, because of that in general I can write the expression d equal to 1 by 2 pi ln xn minus xn, otherwise I could have written x1 by x2, that is also could have been written, but to make generalized I have written xn minus 1 by xn, log of xn minus 1 by xn. So, this is the expression when I will consider successive peak, but sometime to catch the successive peak very difficult, sometime 0 peak I catch and then I nth number of peak I will catch. In that case how to use this one, you can see if I write x naught by xn, that is nothing x naught by x1, x1 by x2, x2 by x3, xn by xn, and you can see these are actually nothing but what, this is all ratio of successive peak, and from this expression we can see x1 by x2 is nothing but e to the power delta. So, that means this is e to the power delta, this is another e to the power delta, this is another e to the power delta, this is another e to the power delta. So, that means and it gets cancelled actually. So, ultimately x naught by xn will be remaining, but ultimately if I put individual value it become e to the power n delta, and that means ln x naught by xn is nothing but if I take log now then it become n delta, and delta is already I have shown that 2 pi d. So, 2 pi d n it become, then your d become 1 by 2 pi n ln x naught by x n. That means, if I measure a peak here, another peak somewhere here after long time, and suppose number is n, and then the ratio of that steep amplitude x naught by x n, if you take the log, that value multiplied by 1 by 2 pi into n will be actually damping value. So, this is another method, that is by free vibration test one can find out the damping by this method, that is called logarithmic decrement method. Now, for finding out the steepness there are theoretical method actually 4 g r by 1 minus b. If you know the g, you can see the steepness can be obtained 4 g r by 1 minus mu already I have told, and from if you know the g then we can find out that. But here actually to find out cu there is a method is given. You can see if I do load versus settlement and loading unloading, if you do, if I P1 load is applied and then removed, then it will not go to the original position, there will be some final deflection delta 1. So, final deflection that is delta 1 corresponding to P1, P2, P3, that delta 1, delta 2, delta 3, delta 4 whatever it is shown, it is final here, and the rebound is here, then what is the, this is called delta phi or whatever elastic settlement. So, whatever rebound is taking place, that is actually elastic settlement. That one actually if you take, so the corresponding, so that load, so this is the elastic settlement delta E and this side actually load, actually nothing but load, is not load, actually it is pressure, actually it is pressure, and then if you plot them you will get it like that, and finally your Cu become P by, so you will get a straight line, and you can take any point over that and find out by measuring P by delta E will be your Cu. From this also test one can, by plate load test one can do it. Similarly, there is a another test actually, that hammer test. If I take a block, and then if I strike it, then vibration will be there, and if I measure at different position, actually arrival time, distance are known. So, the travel time of travel versus distance if you plot, then we get a approximate straight line, and from there I can find out the velocity and V c by this equation, V c equal to S by T, and once you get the V c, you can, using this equation one can find out the elastic modulus E, and after getting the elastic modulus E, one can after getting the elastic modulus E, one can find out G also by using this equation. So, these are the actually some methods given in IS 5249, and there are so many others actually, whatever method we have discussed before also, that is during the soil exploration, that actually there are different methods to find out the G value. So, that method is also applicable. In addition to that, IS 5249 whatever given I have just discussed, and with this perhaps I will stop here about your determination of dynamic properties, whatever given in the IS code. Briefly I have discussed, you do not require everything, but some at least I have covered. With this I will stop here. Thank you.